Okay, so here's what else. Here is what else is important, and that is you need to know this. If your angle today, and by the way, all your answers will be angles. Okay, if your answer is in the first quadrant, that's what your triangle looks like. But here's my question: sine, cosine, tangent. Are they positive or negative in this quadrant?
Positive.
Are they all positive?
Yes.
Because x is what? No. X is positive. Y is what? Positive. The radius is always positive. So would you agree all trig functions are positive in quadrant 1?
Yes.
Okay. How about quadrant 2? What's your triangle look like over here? X is what? Negative. Y is what? Positive. Radius is always positive. So now when you look at this triangle, what's the only one that's positive? Y over R. What is sine? Here's theta. Y over R, is that positive?
Yeah.
Sine is positive. What about cosine?
Negative.
Negative x over R. That's negative. What about tangent? Y over negative x, that's negative. So what's the only trig function positive here? Sine is positive in the second quadrant. You have to know this. You have to know this. Okay, third quadrant. Look at your triangle. It's still going to be negative x. What's this?
Negative y.
What's this? Okay, so what's sine? Negative or positive? Negative. What's cosine? Negative or positive? Negative. What's tangent?
Positive.
Negative over negative, positive. This is the only trig function that's positive in the third quadrant. Tangent. All of them positive here, sine here, tangent here. Guess what's positive?
Cosine.
Yeah. Okay, let's just finish it. Positive x, what's this? Negative y, what's this? R. Okay, so what's sine of theta? Negative over positive. Negative. What's cosine?
Positive.
Positive or positive. There it is. And what is tangent? Negative over positive, negative. Okay. So how are you going to remember this?
STC.
What?
STC.
STC. Okay. Okay. How about this? All students
Take classes.
take calculus?
No.
No?
Did you hear what I said? I said crack.
I prefer Harold.
There it is.
But
All students take calculus, right? Isn't everybody gonna take calculus?
I'm taking pre-calculus.
Good. Well, you'll get here next. Hey guys, every time I do this, so and I say students, S is sine. Sine's positive here. Tangent's positive in the third quadrant. Cosine's positive in the fourth quadrant. You just have to remember this, okay? All right. Now, can we start the lesson? Why not? Say it again.
It has to be that way.
What do you mean by right?
Because it's like different, like they write from right to left, and we write from left to right. So it's
So
like
we have to read it that way.
Yes, you have to read it that way. Oh, I get. Now I get you.
Yeah.
Yes, now I understand what you're saying. Read in the positive, like the positive angle version.
Or that too.
Okay. How do you draw a positive angle? This way.
yeah.
Counterclockwise. Okay. Okay. Let's start the lesson. Here we go. Okay. Now stay with me. Using your calculator, if you like this, using your calculator, find sine of 40 right now. This is a ratio. Give me the ratio. Make sure you're in degrees, by the way. Point.
6427876.
Okay. I think this is good enough, okay? So Harry gives me that. He's right. That is the ratio. Now some of you are saying, that doesn't look like a ratio. It is a ratio. You know what it is? It's 6428 over
1.
You know what this is? This is the tens column, hundredths. thousands, 10,000ths column. What that's telling you is your opposite side is this long, your hypotenuse is this long. That's what it's telling you. But it doesn't give it to you in a ratio form, it gives it to you in decimal form. Okay, so we put the angle and get the ratio out. Suppose you were asked to find an angle whose sine is 0.6428. To do this, you would use the what button?
Sine wave.
Inverse, it's called inverse sine button. So you will type in what's inverse sine of 0.6428, and you really shouldn't have to do this. You should know the answer.
40.
Isn't it 40?
40.0.
Guys, we're going backwards, aren't we? Look, this to here gives you 40, right? So here's the deal. I just want you to know this. Today I'm going to ask you for an angle. This is your answer. You always give me angles in degrees or in radians, okay? Sometimes you get to use your calculator. Sometimes you don't get to use your calculator. You're going to start out with no calculator when we turn the page. Okay, now read this. This is kind of funny. Of course, like they expect you to know this. Sine of 40 is the same as sine of 140, which is the same as sine of 400, which is also the same as sine of 500, and sine of 760. Does that make sense to you?
Because it's the same angle.
Okay.
Roughly.
Well, here's the deal. Watch this.
Like one more pascal.
But watch this. It says here, you're telling me the sine of 40 degrees,
They're all 30 degrees.
okay? If we did opposite over hypotenuse, you would get this answer, 0.6428. But here's the deal. There's two answers. Sine is positive here. Where else is sine positive? Here. So you should also know if you flip that triangle, you're going to still have, aren't you still going to have the same opposite over hypotenuse look? Isn't this distance and this distance same as this and this? So what's the other angle? 40 is one answer, but what's the other one? How come? Because this is 180, right? Take away what? 40? That would be the same as 140. Okay, where's this 400 coming from? Yeah, 400 is this angle. Where's 500? This one. Where's 760? Back to this one. So those are, what do we call those? Coterminal. You got it. Those are just coterminal. That's all they are. So you could type in, hey, you guys could all type in 760 degrees sine. You're going to get that answer. It's just that it's just disguised. It's really, I think this one's really this one, I think. Okay? All right. Now, enough about inverse sine, cosine, tangent. Let's talk about what your calculator's doing. What is your calculator actually doing? There are so many answers. Guys, I can make a circle. That's the answer. That's the answer. That's the answer. It's the same answer. So your calculator was programmed to give only what? One answer. Because to be a function, if you put in a number, to be a function, if you put an x value in, how many answers do you get out? One. So your calculator's been programmed. Now I'm gonna do this quick. Your calculator, I'll just put calculator, was programmed to do this one, inverse sine. Where's it going to give the answers? Right here. All positive ratios, all the angles will be in here, from 0 to 90. All negatives will be here. From 0 to what? Negative 90. There. This is what your calculator does, and that's all it does. It never talks about any of these. So even though 40 was the answer, so was 140. Your calculator doesn't care. It's only going to tell you what? 40. Okay? So write this in. Theta, your answer will be between, it'll be greater than negative 90 up to positive 90. If I was talking radians, it would be greater than negative pi over 2 up to pi over 2. Okay? I'm just trying to tell you what your calculator does. That's all I'm doing. So what does your calculator do for inverse cosine? All positive answers here. from 0 to 90. Agree? All negative ratios get these angles. So what quadrants am I in for cosine? All your answers will be what? First quadrant or second. From what to what? 0 degrees to what? So greater than 0 degrees, but less than 1/8. Or if we're talking radians, greater than 0 radians, but less than pi radians. Okay? These are the answers your calculator will tell you. I just want you to know, if you punch in a negative ratio, you get this quadrant. If you punch in a positive ratio, you get this quadrant. Okay, last but not least, tangent. What happens when you start talking about inverse tangent? We're going to talk about positives here, 0 to 90, negatives here. So this looks like inverse sine. Inverse sine and inverse tangent go together. So you'd say, oh, I can go as high as 90 or as low as negative 90. So I suppose here I'd put negative 90 up to 90. When it comes to radians, negative pi over 2 to positive pi over 2. Okay? I will keep talking to you about this. You will eventually get what I'm saying. The only one that's really weird to me is cosine, because cosine positives are here. Where are the negatives? Second quadrant. So this one's different than sine and inverse tangent. Okay? Inverse sine and inverse tangent are identical. Okay. Now I'm ready to begin your problems. Here's what your assignment looks like today. Your job is to do all of these. But before you do it, you have to understand it's without what? Calculator. Okay, so here's the deal. To start this, you need to copy your 30-60, your 45-45, and your unit circle on top of your notes. Okay? And because I'm recording this lesson, they can't see these triangles. So I'm going to go to another slide. And if you're listening to this lesson, let's put down our 30-60s. Put your numbers in the right spot. And then do your 45-45. And if it's not one of these triangles, it's got to be the unit circle. Sorry, my unit circle got a little too close. These three things will tell you what angle you're looking at, okay? All right. Can I say you're done? Are you done? Are you guys done copying that?
Yes.
Okay, let's go. Ready? Inverse sine of what? Inverse sine of negative 1/2, right?
Cosine.
Oh, sorry. Inverse cosine of negative 1/2. Okay? Well, here's the deal. Start by doing this. Where are your answers going to be for inverse cosine? First quadrant. Who's got this Slurpee? Put it away, Hannah, please. And then your negatives are over here. Okay? So guys, right away, do you know where your answer is?
Yes.
Where is it? Yeah, it's right here. It's in quadrant 2. It's going to be 100 and something. Okay? It's not over here because you have a negative ratio. Now, next thing you want to say is I've got a ratio of 1/2, and then you got to go to your special triangles and pick the triangle that has a 1 and a 2 in it. Yeah, it's this one. Okay, now we're doing cosine, right? Tell me, cosine, either pick this or pick this. Let's pick 60. If you did cosine of 60, what would cosine be? Adjacent 1 over hypotenuse 2. Is that what you wanted?
Yeah.
Did you want 1/2?
Yeah.
You got it. It's 1/2. The answer is what? 60. We got it on the first try. If this didn't work, I would have tried the 30. You know why 30 doesn't work? What's cosine of 30, guys? Square root of 3 over. That's not what I wanted. I wanted 1 over 2. I got it. 60 degrees is the answer. Now you got to go back here and then put your 60 in the right spot. You're in this quadrant, so your triangle looks like this. Okay, you got a little 60 right here. This is called the reference angle. Now you know the answer. What angle gives me negative 1/2? 60 degrees. But you're in the second quadrant. The answer is, what is this right here? How far is that? 120 degrees. That's the answer. What angle gives me this ratio 1 over 2? It's it's 120. Now, in radians, you can just do this. Or, I have a feeling some of you know radians pretty well now. Do you know what it is? No? Okay. Can I ask you this? If you counted by 60s, ready? That's 60. That's 60. How many 60s are in 180? There's 3 of them, right? So they're count by thirds. Since you got 120, how many did you go? 2/3. You went 2/3 of pi. So this is 2/3 pi. Now if that doesn't make sense, then just do your multiplication. Yeah, this cancels out. 60 goes in here twice. 60 goes in here 3 times. 2/3 pi. That's the answer. Now, I'm hoping some of you can count a little quicker than that. 60, 60, 60. We're talking thirds. We went 2/3 of the way. Next one is what? Sine of?
-1/2.
Okay, negative 1/2. Okay, so put that over here. Now, what angle will give you this? Well, first you should start out by saying, where is sine defined? Sine is defined here for positive ratios. Here for what? Negative ratios. You have negative. You're in what quadrant? Fourth. You're in the fourth quadrant. Now you got to go pick an angle that gives you 1 over 2. Here we go. 1 over 2. Here's a 1. Here's a 2. Sine. Is sine of 60 1 over 2, or is sine of 30 1 over 2? Sine of 30. Sine of 30 is 1 over 2. The answer is 30 degrees, except the ratio was negative. And because the ratio is negative, we're down here 30 degrees, right? Think about it, guys. What would the leg be here? Yeah, and the hypotenuse? 2. So doesn't this work? 30, sine of negative 30 is negative 1 over 2. That's what they're asking me. 30 degrees. Negative. In radians. How many 30s go into 180?
6.
6. We're counting by 6. Well, we only went 1 30 degrees, so it's going to be 1/6. Again, if you can't do that, you're going to have to multiply by pi over 180 and do it the long way. Okay, next. Inverse tangent of, is it just 1?
Yes.
Okay. Well, this is 1 over what, though? 1. If I write it as a ratio, it's 1 over 1. Which triangle are we looking at? Yeah, guys, it's 1, 1. Look at this triangle. Now, but you got to ask yourself, is tangent of 45 1 over 1? Yeah, opposite over adjacent. It works. It's 45. Now you should probably say something like, where is tangent defined? Here for positive, here for negatives, right? And you just told me it was positive 45. Okay, so the answer is 45 degrees. This is 1. This is 1, and this is square root of 2. Is tangent of 45 1 over 1? Yeah. Okay, comma.
Pi over 4.
Pi over 4. Good? Okay, you guys aren't raising your hands, so I'm just kind of cruising here. All right, next. Okay, square. Where is what angle will give me inverse tangent of square root of 3 over 3? Gotta look. Yeah, which triangle has a square root of 3 in it? It's the 30, 60. Now you just gotta ask yourself, is it 30 or is it 60? 60? Okay, ready? We want tangent. Opposite over adjacent. Is the square root of 3 over 1 the same as the square root of 3 over 3? No.
30
Or is it 30? What's the opposite? 1 over the square root of 3. Hey, I did this problem last hour. 1 over the square root of 3, if you rationalize, you get square root of 3 over 3. Okay. So this is the answer, right? This is the ratio they were asking you about, so you should say it's 30 degrees. That ratio is negative. Okay, where is tangent defined? First and fourth, positive here, negative here. You got negative, so you'd be here, wouldn't you? What angle did we decide on? 30. Negative 1, square root of 3, over 2. Hey, just look at your triangle. Is tangent of this angle negative 1 over square root of 3? Is that going to be this? Yeah, I just did it. I just did it right here, guys. So, yeah, it works. It's negative 30. Which ends up being negative pi over 6. Okay. Is your head spinning yet, or are you okay? Some of you are going, yep, my head's spinning. I mean, that's fine. I mean, you don't get this stuff until you've done it over and over. Okay, try that one. Go look for a triangle that gives you 1 over 1, or is that negative?
Negative.
Okay, go look. See what you can find.
Then when will we be using the unit circle?
You'll see. It's coming. Okay, you ready? 1 over 1. By the way, it's negative, so you should know your answer is where? Up here or down here? It's down here, guys. Your answer's down here. Okay? Now, what triangle has a 1 and a 1 in it? 45. Guys, ask yourself the question. Ready? Is sine of 45 1 over 1? Yes? Did you say yes? Sine?
No.
Sine of 45 is 1 over square root of 2. Is 1 over square root of 2 this? No. No, you guys. You can't look and say 1 over 1 is got it. It's got to be 45. No, it's sine. Sine of 45 is 1 over square root of 2. That's not that. Okay, and you don't, in this triangle, you don't have the nice number. So you kind of, this doesn't work, this doesn't work, guess what works? We're at the unit circle, guys. Let's go to the unit circle. So we're looking at this, aren't we? Sine, inverse sine of what? Negative 1 over 1. You have to understand that this top number is the y value. The bottom number is the r value. Where do you see y? Negative 1. Right there. Where do you see the radius to be 1? How about everywhere? Radius 1, radius 1, radius 1, radius 1. So this doesn't this look like, what degree is this? What do we call that?
270.
Don't go that way.
Negative 90.
It's negative 90. Yep. The answer is negative 90. Or negative what over what? Pi over 2. Radians, degrees. Did I do that wrong? Yes, I did. It's right here. Sorry, this is the answer. Negative 90 or negative pi over 2. Okay, sorry, I'll get rid of this. Okay, now try inverse sine of 1/2. Pick the right triangle. Which triangle has a 1 and a 2 in it? Yeah, it's this one. Okay, you have two choices. Do you think it's 30 or do you think it's 60? Do you think it's 30? What's opposite of 30? 1. Hypotenuse. 2. Oh, it is. You guys, you got it. You got it. It's 30 degrees. And because this is positive, you're in what quadrant? You're in the first quadrant, right? So you're here. I'm going to draw you the picture again. Positive ratios here, negative ratios here. You guys decided on a 30, didn't you? You know, if you think it's 30, you should actually draw the triangle and put your numbers in. 1, 2, square root of 3. And then you should ask yourself, does this even make sense? Sine of 30? Is sine of 30 1 over 2? Yeah. So that ratio, inverse sine of that ratio, should pump out what angle? 30 degrees. Okay, what is that as radians? Radians? 5 over 3? Are there 3 30s in a pi?
6.
Oh, did you say 6? Sorry. Okay, it is 6, right? 5 over 6. Okay, last one. Go. This is the last one you have to do without your calculator. 2 over 1. What angle creates a ratio of 2 to 1? 2 over 1. Y over R, opposite of hypotenuse. Travis, what is it?
Well, what is it? Secant it would.
No, I didn't ask you what secant. Don't switch functions on me. I want sine.
No clue.
Which one do you see?
Well, it's 1, 2, right? Okay, 2 over 1 is what it is. Okay, let's try that. Let's go here. I see a 1, I see a 2, guys. Okay, it's sine. What's sine of 30? Is 1 over 2 2? No. Okay, how about this one? Sine is what? Square root of 3 over 2, is that 2? Doesn't work. Go to this one. Sine of 45. This over this. But that makes the square root of 2 over 2. That's not 2. It's not working. Let's go to this. Okay, guys, here's what you have. You have, oh, sorry, you don't have that. You have this. You have negative, no, you have 2 over 1, don't you?
Yeah.
Okay, y over r, ready? First of all, where do you see the radius 1? Everywhere. 1, 1, 1, 1. Where do you see a y value of 2 on here? You don't, do you? Guys, this is not working. Nothing worked there, or here. Do you know why it's not working? It is undefined, but do you know why?
Because it doesn't make sense.
It doesn't make sense, but you got to think of it like this. Okay, ready? Oh, it's positive, sorry. You know what this says? Opposite over what? Hypotenuse. Look at this. Look at this. You're telling me the opposite side of theta is 1. Or sorry, you're saying it's 2. You're saying the hypotenuse is 1.
Opposite leg can't be more than the hypotenuse.
Yeah, the longest side of a triangle is the hypotenuse, guys. This isn't going to work, is it? This has to be the longest side. That's why we call it undefined. The answer is undefined. So, undefined. Okay. Now we get to use our calculator, and guess what? We're out of time, but we can sneak this one in. Ready? Type it. Type it in. Type it in. Point
158.
one what?
158.
Okay, 6. Right? 158.
Yeah.
Okay. They want it in radians. What are you gonna do?
Converted.
Times pi over.
Two ways you can do it. One, this is how you could do it. Or the other way is change the mode of your calculator to what?
Radians.
Radians, and then type it in.
That's a lot of word.
Just type this in again. Okay. Answer was, you got it?
So you're coming.
Make it 1.12 is the answer. Hey, don't walk out without that blue worksheet right there. Blue worksheet. Okay.
Yeah, come in, let's go for like 5 or 10 minutes.
Yep.
On the yellow.
Yep. Then I'll try to find your test. I know what's in there. I must have totally just, I was going through it and missed it. Pretty sure it is. Because I do remember you taking the test.
Yeah.
Okay?
Yeah, you can do